Good day, everyone. We will be looking at how to calculate Centroid for mathematics and 6. So here we've got a question. I will take us through the question. It says we should calculate the point of intersection of the two graphs. My first graph is there, y equal to 2x squared, and the second one is y equal to 3 minus x squared. Then after that, we'll make a neat sketch of the two curves and show the strip that we use to calculate the area bounded by the two curves. So, from what I have picked up in that question, you see I've underlined what is important to me. I've underlined two graphs. So I'll start by getting those two graphs. So in the A part of my problem, I have two graphs, y equal to 2x squared. That is my graph number 1, and y equal to 3 minus x squared. That's my graph number 2. So what this tells me is that when I'm done sketching the graphs, the portion I'm shading must be surrounded by the two graphs. That's what they indicated there. But they need point of intersection from us. So to calculate point of intersection in graphs, we just substitute one graph into the other one. So I'm going to substitute equation number 1 into equation number 2. So if I do that, it means I'll be taking 2x squared there into the position of y in the second equation, which will be 3 minus x squared. And when you are solving equations, you must make sure that 0 is on one side before you calculate your points. So I will take all the two terms to the left. If I take this one to the left, it will become positive x squared, which will add to 2x squared to give me 3x squared. Then 3 will become negative on the left. So again, negative 3 is equal to 0. And now the degree is the highest power of x, immediately tells me that I must get two answers when I solve. So you can choose to pass this through the quadratic formula if you want, but if generally when the terms are less than 3, it's easier to solve by factorization. So with factorization, I'm taking out 3 as my common factor. So if I do that, I'll get my x squared minus 1 equal to 0. Then if I divide both sides by 3, that gives me x squared is minus 1 is equal to 0. So that tells me that I've got x squared is equal to 1. If I take the square root of both sides, I will therefore get x is equal to positive 1 or x equal to negative 1. So those are your x values, they are not point of intersection. So in that way, I have to continue now to get the y values. So to get my y values, so x equal to 1 and x equal to negative 1 are not points of intersection, because a point must get an x value and a corresponding y value. So we've got the two x values. We'll now substitute each into any of the equation of our choice. So if I take x equal to 1 into the first equation, it shows to me that y will be equal to 2, because if you put 2 there, 2 times 1 is 2. Then if I put x equal to negative 1 there, it will also be 2, because negative 1 squared is 1 times 2 is 2. So therefore, my point of intersection are 1 and 2 for the first. The other one is negative 1 and 2 for the next. So I've got my 2 points of intersection. I can now sketch my graphs. So when you are sketching graphs and you are lucky to get point of intersection, they make the sketching very easy, because all I need to do is go and plot this point first. So my point, I need on the x a positive and a negative, so that immediately tells me that the x-axis is highly involved, with one point on the positive side and another one on the negative side. So this is my x-axis, I can put my 1 there, and I put my negative 1 there, then that is my 0. Then for my y values, you see they are all the same, they are 2, so I can choose to put mine 2. Where can I put my 2? Let me just put it here. Then, we're doing a sketch, we're not drawing to scale. So when I look at the first graph and the second were all parabolas. So we are fond of calling this one the smiling face, and we call this one the sad face because we look at the value of A. You see that A there is 2, which is positive. A there is negative 1, so that is negative. So it shows in the shape. So both graphs are supposed to pass through the point of intersection. So my point of intersection are 1, 2, is this one, and negative 1, 2. So those are my points of intersection. So I get negative 1, 2, and 1, 2. So for the sad face, or let's start with the sad face, this one, it has to pass through those points of intersection, and to make it complete, if I want to know where it touches the y-axis, I just make x 0. If I make x 0, you see it will touch the y-axis at 3. So if I put my 3 there, then it means the sad face is a graph that passes like that. So that is my sad face. Then the smiling one will pass through the 2 points of intersection. If I want a third point, because to sketch a parabola, it's not like a straight line, to be very sure of everything, you need at least a third point. If I need a third point, I can just go to the graph and make x 0, we'll say y is 0. So the point 0, 0 is the origin. So the other graph will be something of this nature. So you see, I've succeeded to get the two graphs. So the two graphs are both passing through the point of intersection. So it's now time to put a strip in the portion bounded by the two graphs. So the portion bounded by the two graphs given to me should be this one. They didn't give us any restriction whether we stay in the first or in the second quadrant. So we don't have that restriction. So I'm shading everything. So that is the area bounded by the two graphs. So if I'm to put a strip in my shaded portion, there is one important thing you should know about a strip. For it to be a correct strip, it should touch two graphs all the times. So the best option I will go for is a vertical strip, because if I put it on the right, I keep on touching the same two graphs. In the middle, the same two graphs. On the right, the same two graphs. So this immediately tells me that a vertical strip is the best strip here, and I can put it anywhere I want. But if you go for horizontal, you see up there, the first problem is that a strip is not supposed to touch the same person. You see, I'm touching the same graph, and the graph is even changing. So it makes a horizontal strip a little bit of a problem for me. So I'll go for a vertical. I can put it on the right, or the left, or in the middle. So I'll choose to put it here. So that is my strip. Then if I extend that strip out of the shaded portion, it takes me to the x-axis. So I'm putting there. That reminds me that if I go to the B part where I'm supposed to calculate the area as an N6 student, you check for that formula on page number 4 of your formula sheet that ends with Tx. So your formula for area is already picked for you. So that will be a formula for area. It must end with Tx because my strip is saying so. Your strip is the most important thing in your graph. And also that formula is reminding you that in your diagram, you need to know what is your y1 and what is your y2. So because I've used a vertical strip, I must label the two graphs that my strip is touching with y1 and y2. y1 passes above the strip, y2 below the strip. So my y1 is the graph that passes at 3. It is the second graph, so that is 3 minus x squared. My y2 is the graph that passes below the strip, and that is the first graph. So my y2 is this one, so that is y2 equal to 2x squared. Let me label it maybe this side. So my y2 is equal to 2x squared. So with the A part of the problem I'm done. I've calculated the point of intersection, the idea. I've sketched the two graphs. I've indicated the area bounded by the two graphs through shading. I've put a strip in there, which is a vertical strip. So it's now time to calculate the area. The strip has helped me choose my formula for area for me. Once you extend your strip, it touches the x-axis. It tells you how to get your formula. So all I need now is to substitute into the formula. So if I'm substituting, my y1 is the upper graph, the graph above the strip, That's my y1 minus my y2, which is the graph that passes below the strip, then dx. Then to read your a and b, we read it from the graph where we started shading to where we stopped shading. On the x-axis, you see the formula ends with dx, so it tells us where we read our limit. So our limit a and b is where we started shading. We started from -1 on the left, we ended with +1 on the right, on the x-axis. If my formula was ending with dy, then I will be reading from 0 to 3 on the y-axis. So my limits are from -1 to 1 dx. So if I open up those brackets in there, I'll get the integral from -1 to 1 of 3 minus 3x squared, because this negative x squared and negative 2x squared are like terms. Then I can now integrate. I'll get 3x minus x cubed when I do my integral, because when you integrate x squared, it gives you x cubed over 3, which will eliminate this 3. Then I can now substitute my limit. The upper limit is 1. If you replace every x there by 1, I'll get 3 minus 1. Then minus the lower limit. If I replace every x there by -1, I'll get -3. Then this will be plus 1, because -1 cubed is -1, combined with this negative is positive. So in my area, I get 2, and this one is -2. And another negative makes it +2, so this is like 2 plus 2, or can I say 2 minus -2? In that way, the two negatives become positive. Then we see that our area is 4 unit square. So that is how we get our area in that problem. So you see, it's something so easy. So we can now look at the last part of the problem. The last part of the problem says we should calculate the distance from the centroid to the x-axis of the area. So this is one thing that students of N6 must be familiar with. When they say distance from the centroid to the x-axis, this is another name for the y-coordinate of the centroid, what we call y bar. So all you need to do is go to page 5 of your formula sheet as a Math N6 student, look for a subtopic called centroid, then you look for the formula for y bar. So that's the distance. So as I was saying, the distance from the centroid to the x-axis is y bar. If they wanted to make life easy, they will just say calculate the y-coordinate of the centroid. So those are the things you must know. The same thing as distance of centroid from y-axis will become x bar. So that is what we are looking for in the C part of the problem. We are looking for y bar, the y-coordinate of the centroid. So as an N6 student, you just go to page 5 of your formula sheet. Under the subtopic centroid, you look for the formula for the y bar, which is the distance of the centroid from the x-axis. So this is what you are going to see as your formula. So in this formula, you remember the denominator is the area, which we've just calculated before. So our target now is the numerator. So the numerator is called the area moment about the x-axis. So the formula for area moment is just above the formula for centroid, which is defined for Math N6 on page 5 as the integral of r dA. So it now becomes your responsibility to develop this formula with the help of the diagram you have drawn. So you must develop this formula. So when I'm developing this formula, dA is simply the formula for the area I used. That's my dA. It becomes the formula for the area. So I simply copy down my area formula, integral from a to b. I will leave some space for r because I'll come back to r. Then I have my y1 minus y2 dx. So that's my area formula. Now, the interesting one now is r. So to define r, this x-axis here plays a very, very important role. So I must go back to my diagram. I start from the center of my strip. I move in a straight line until I meet the x-axis. So I'm going to do that. I'm going back to the diagram I've drawn. I'm starting from the center of my strip. I move in a straight line until I get to the x-axis. So that is my movement. So usually I explain to the students that if you can start from the center of your strip and you move to the x-axis as instructed by the formula, if this dotted line I've put there moves in the same direction as my strip, then my R will become the average of the two graphs that my strip is touching. You can see very well that your strip touches a graph above it, we call it Y1, and a graph below it, which we call it Y2. So the first thing is that the fact that I did a vertical movement, every vertical movement is supposed to be described using Y. But because the strip and the dotted line are in the same direction, I use the average. So the mathematics behind it is simple. The strip is just actually like a vertical line. That strip you see there, we can reduce it to a vertical line. This line has Y1 at the top, Y2 at the bottom. You see your Y1 passing at the top, Y2 at the bottom. Then R, the distance is always coming from the midpoint. So we all know how to calculate the coordinate of the midpoint. It's Y1 plus Y2 over 2. So that is the mathematics behind it, but the simple way to pick it out is that if you go to your diagram, you move to the x-axis as instructed by the formula. I started from the center. If I move to the x-axis, I'm supposed to be, that's the vertical movement, I'm supposed to use y, because the strip moves in the same direction, I use the average. So my R will be a simple average of y1 and y2 over 2. So if my strip was not vertical, my R would be a simple y. So that's how I get my R. Then this 2 is at the denominator. In integration, I practice taking out all constants. So that 2, because it is at the denominator, it becomes a half. Then y1 plus y2 into y1 minus y2 is just the difference between two squares. So that should give me y1 squared minus y2 squared dx. So you see I've developed that formula with the help of my diagram until it looks like this. So I can now start my process of substitution. So a and b, the same a and b I used under the area. My y1 was 3 minus x squared. So I have to take 3 minus x squared and I square it again, minus my y2, which is 2x squared, and I square that again, then dx. Then I will take my time and open the bracket in there, starting with this one. So to expand 3 minus x all that squared, as an N6 student, you must get used to this kind of expansion. From expanding a plus b all that squared, it's very simple to do it fast. You just take a, you square that, it gives you a squared. You square negative b, you get positive b squared. Then in the middle, you just take 2 times a times minus b. Then you have 2a. That's how fast an N6 student can expand. You don't need to waste your time taking a minus b to a minus b. That is meant for high school students. So I will try the technique here. I take 3, I square it gives me 9. If I square negative x squared, it will give me positive x to the power 4, because each time you square a negative number, it becomes positive. Then in the middle, I will take 2 times 3 times negative x squared, that gives me negative 6x squared. So you see, in just a short while, I've done my expansion. I don't even need to go to a half page to do that as an N6 student. So I will just write my 9 minus 6x squared plus x to the power 4, then minus, this minus now is this one. Then if I square this item, it's one term, I will get 4x to the power 4. Then dx. So that is my expansion. Looking at my expansion, there are like terms involved. so I can pull the like terms together before I can go to integration. So if I continue this side, my area moment about x becomes 1 over 2, the integral from minus 1 to 1 of 9 minus 6x squared, then x to the power 4 minus 4x to the power 4 becomes negative 3x to the power 4 dx. So I can now comfortably do my integration. If you integrate 9, you get 9x squared, then followed by, can I say 2x cubed, since when you integrate x squared, it gives you x cubed over 3, 6 over 3 is 2. Then, if I integrate the last one, I will get 3 over 5x to the power 5 from negative 1 to 1. Then I can put my upper limit, which is 1. If you replace everything by 1, you will get 9 minus 2 minus 3 over 5. Then minus, if I replace everything by minus 1, this will be negative 9. Negative 1 cubed is negative 1 times negative 2 is positive 2, then plus 3 over 5. You may not forget the negative sign outside. So I can now go to my calculator and take my time to do the calculation. So here 9 minus 2 is 7. So I have 7 there minus 3 on 5. That's my first bracket. Then if I open this, I will be getting plus 9 because of the negative sign, minus 2, then minus 3 over 5, minus 3 on 5, then I multiply my answer by 1 over 2, since 1 over 2 is a common factor. So from what I'm seeing, I will get that 2 over 5 as my area moment about x. If you are interested in unit, it is u to the power 3, since the formula has dA, which is u squared, and r is u. So now that I've succeeded to get the area moment about x, I'll just divide by my area. My area, I got it as 4. So therefore, my y bar, which is the y ordinate, or the distance of the centroid from the x-axis, is area moment about the x-axis and divide by the area, which is 4. So if I do this division, I'm dividing by 4. So my answer becomes y bar equal to 8 over, is it 8 over 5? In decimals, I'm interested in the answer in terms of decimals, which is 1,6 unit. It's always important to put your answer in decimals, because if this answer is right or wrong, you can pick it from your diagram. So our answer is saying the y ordinate is 1,6. If I go to my diagram, I can pick it up, because we are looking for the center of this shaded portion. If you look at the shaded portion on the y-axis, it lies between 0 and 3. For your answer to be correct, it must be a number between 0 to 3. If we're looking for the for the x value, which is the x bar or the x ordinate of the centroid, you see the shaded portion lies between 0 and 1. It should be an answer between 0 and 1 for it to be correct. So, guys, thank you very much.